Howdy, PreCal. It is Miss Kosh. I have a hint of a cold, so I apologize in advance if I sneeze. In the meantime, we are going to do special right triangles and trig ratios. I'm working off of Mrs. Bellish's notes, and we're going to see how we like it. So the first thing, we have got to have the same foundation when we're talking about all this stuff. So hopefully this is a little bit of a review, but I don't go too slow. So notice if we are looking at an angle, if we have focused in on angle B, when we go across from the angle over here, that is what we refer to as the opposite side. So it's opposite of the angle that we care about. The hypotenuse is always, always, always across from the right angle. So when you see the right angle and you go across, that is the hypotenuse. And the adjacent is the other one. Okay, so if this was the opposite and this was the hypotenuse, then the adjacent has to be the one. It's adjacent to this angle. See, that's why we call it the adjacent. Okay, and so another important thing, when we name pieces of a triangle, the lowercase letters represents side of a triangle, and the uppercase letters represents the angle. Okay, so and the cool thing is we put them across from each other. So if this is angle A, then little a is over here. If this is angle B, here's little b, this is little c. And so if we're talking, if this is our angle theta, and theta is that Greek letter that we often use for a variable for an angle. We use that a lot for angles. If this is theta, then here is the opposite of theta, here is the adjacent to theta, and here is the hypotenuse. On the next one, we have here is little a, this would be little b, this would be little c, this would be opposite theta, this would be the hypotenuse, and this would be adjacent. Okay, the next one here is little a, here is little b, here is little c, here's the right angle, so across from the right angle, do that first, that's the hypotenuse. Here's the angle we care about. Hang on, let me get rid of that. Here's the angle we care about, here's theta, and so across from it over here is the opposite, and then the one that's left over is the adjacent. I think I'm going to skip some of these for right now, but that policy, that idea works for all of these. Okay, and so now, actually, before we do that, let me add a page. If I have a triangle, and I have this side has a length of 4 and this side has a length of 4, and I'm trying to find this. I can use the Pythagorean theorem and get 4 squared plus 4 squared is equal to x squared. This is 16 plus 16 is equal to x squared. I get 32 is equal to x squared. Then I can square root. I'm not going to do the plus or minus because it's a side length and we only want a positive side length. And when I do that, 32, if I divide by 2 and divide by 2 and divide by 2 and divide by 2, I end up with 2 pairs of 2 and a 2 left over. This is a 2 times a 2 times the 2 left over, and the square root of 2. This is 4 root 2. Okay, let's look at another one. If I have a triangle where I know that this is 6 and this is 6, then I can say 6 squared plus 6 squared equals, we'll call this x squared. This is a squared plus b squared equals c squared. This is 36 plus 36 is equal to x squared. This becomes 72 is equal to x squared. When I take the square root, I don't want the plus or minus because it's a length. Then what I want to do, I have 72, I can divide that by 2, I get 36, I can divide that by 2, I get 18, I can divide that by 2, I get 9, divide that by 3, there's 3. I have a pair of 3s, they get to go out, I have a pair of 2s, they get to go out, and a 2 stays home. So it's a 3 times the 2 times the square root of 2 is equal to x. This is 6 root 2. Hopefully, you've seen this before. Hopefully this is not brand new to you. But what we just discovered is that if I have a triangle that's got this side here congruent to this side, if this is x and this is x, notice I just saw 4 root 2. I saw 6 root 2. If I do x, let's call this c for right now. If I have x squared plus x squared is equal to c squared, then this is 2x squared is equal to c squared. When I do square root, I don't want the plus or minus because it's a length. Then this gives me the square root of x squared times the square root of 2 is equal to c. Well, the square root of x is just x, so this becomes root 2 times x, or x root 2. however you want to write this, is equal to that. Why aren't I getting an equal? There it is. So basically, here's the short answer. Anytime I have a situation where the two legs are equal, then the hypotenuse will be times, will be that same length times root 2. Okay, this, and if this is, if we have an isosceles right triangle, these angles both have to be 45 degrees. So we end up with a 45, 45, 90, and so 45, 45, 90, and what we get is x, x, x root 2. That's not a root 2, x root 2. And this triangle, I don't love this one. Oh, I did it in the wrong spot. No wonder I didn't love it. Okay, I'm so sorry. Slide that over here. There we go. So here is our triangle. Nope. Here is our triangle. This is our right angle. This is the 45-degree angle. This is the 45-degree angle. These are congruent to each other. And so this is, whatever this is, that's the same, and this is that times root 2. The 30, 60, 90, we can generate in a slightly different way. I'm going to show you where it comes from, just because some people might think that's cool. With the 30, what we'll do is we'll start with an equilateral triangle and drop in an altitude. If this is 60 and this is 60, then when I drop in the altitude, that becomes 30. Well, if this little piece is x and this little piece, that other side would also be x, and that means this is 2x. Or let's do it with real numbers this first time. Let's say that this is 3 and this is 3, and therefore this is 6. So if I'm trying to find the height of that triangle, h squared plus 3 squared equals 6 squared. H squared plus 9 equals 36. Subtract h squared is equal to 27. Divide 27 by 3, I get 9. Divide by 3, I get 3. Here's a pair of 3s, and a 3 has to stay home. So h is going to equal 3 root 3. Okay, so what we just found is that in this triangle, when this is our 30 and this is our 60, we just found that this was 3, this was 3 root 3, and this was 6, which is 2 times 3. Okay, so and this will extend out to any 30, 60, 90 where we have that situation happening, that ratio going. So here's our 30-degree angle. Here's our 60-degree angle. The 90 was already labeled. Across from the 30 is x. Across from the 60 is x root 3. And across from the 90 is 2x. If you think about it, we have the numbers 1, root 3, and 2. And if we put them in order, 1 is less than root 3, which is less than 2, because 2 is root 4, and so root 3 is smaller than root 4. Put them in order like that, then they go from the smallest angle, would be the 30-degree angle, to the biggest angle, which is 90. So this becomes, so if you put them in order, the smallest angle and the smallest sides like that, that helps, I think. So across, then we have the 30, the 60, the 90. Across from the 30 is x, across from the 60 is x root 3, and across from the 90 is 2x. Think of 1 is less than root 3, which is less than 2, and we're going from the smallest to the biggest. Okay, hopefully that was I went faster than I would in geometry, but I'm assuming that you did see this in geometry. This, ladies and gentlemen, was the most important thing you were supposed to learn in geometry. So I will have plenty of practice for you if you would like it, or even more than what I require. So make sure you practice. Okay, so here is a 30, 60, 90. They gave us a cross from the 30. So then this becomes, this is x root 3, and this is 2x. So this becomes 4 root 3, and this becomes 8. So find the missing sides. Okay, so we could say what we didn't know is little b. Oh, I'm so sorry. It is minutes away from Thanksgiving break, so my brain. Okay, next one here is a 45, 45, 90 triangle, and so this is 6 root 2. And that would be little c is equal to 6 root 2 if we wanted to write it that way. Okay, now we've got the hypotenuse. So this one it's going to be x root 2. Well, if x root 2 equals 9 root 2, we just divide away by root 2. And when you have the same thing top and bottom, they divide, it gives you 1. And so x equals 9 times 1, which is just 9. And so these are both just equal to 9. Hopefully you have practiced enough. When I see this, I did not need all of this for myself. I just did it for you. I look at this and like, oh, the hypotenuse 9 root 2, these two legs are both 9. Hopefully you get that fast also. Okay, here is opposite the 30, opposite the 9, so, and here's the 60. So this is x, this is 2x, this is x root 3. I didn't do it in the right order, I'm sorry. The smallest is here, the middle is here, and here's the largest. All right, we can get rid of all that. So what I know is that 2x is equal to 1. That means that x is equal to 1/2. So this is 1/2, and this is root 3 times 1/2, or we will say root 3 over 2. Here is a 45, 45, 90. Okay, so this was the one that was x. This is going to equal x root 2. So now I have to divide by root 2. And we're going to rationalize. So we're going to multiply by what I call a funky form of 1. So this is a funky form of 1. And that gives me a root 2 over 2. So both of these, root 2, are root 2 over 2. Okay, 30, 60, 90. Here's the 60. Okay, this is a little, this is about, well, okay, we could put a really gross number there, and then this gets a little harder, but that's the more difficult side to work with. And so I have to divide by root 3. And so I multiply by a funky form of 1. I get 15 root 3 over 3, and hopefully you recognize that 15 divided by 3 is 5 root 3, and that will be opposite the 30, that's 5 root 3, and then opposite the 90 is 2 times that. So here, I'll write it. 2 times 5 root 3 ends up giving me 10 root 3. Super. Okay, let's see what's next. SOHCAHTOA. Oh, I teach this slightly differently. Oh, okay, well, here we go. Sine is opposite over hypotenuse, and what we will find here is, this is what we call the reciprocal identities. And the reciprocal identities tell you that sine of the cosecant of theta is equal to 1 over sine of theta. So it's written as cosecant. We say the word cosecant right here, but we abbreviate it CSC. We don't say CSC, we say cosecant. And it's equal to 1 over sine of theta, which would be the reciprocal of opposite over hypotenuse. So that becomes hypotenuse over opposite. Okay, so to be perfectly honest with you, what I have memorized is I have this part memorized and this part memorized, and I can generate this if I need to. So I use those 2 boxes to lead me to the other part as I need it. Okay? Cosine, oh, and this is the sine is opposite over hypotenuse. So SOHCAHTOA. I heard something that was not school appropriate that might help you remember it. It's not school appropriate. Don't do drugs. Drugs are bad. Okay? We're clear? All right. It was some old hippie caught another hippie tripping on acid. Okay, not school appropriate, but it might help you remember the identity, the ratios here. Okay, so cosine is adjacent over hypotenuse, and secant is 1 over cosine of theta. And so it's going to be the reciprocal, it's going to be hypotenuse over adjacent. And once again, I have this memorized. It will not fall out of my head. I know that forever. I have this memorized. It does not fall out of my head. And then I use those 2 pieces to come up with a third. I don't really have hypotenuse over adjacent memorized. I derive it every time. Okay, tangent, the last one here, is opposite over adjacent. And cotangent is 1 over tangent of theta, which means it's going to be adjacent over opposite. Super. Okay, so now we are going to solve. Okay, so here is our triangle. They have told us little a equals 3. They've told us little c equals 5, and I recognize that b is equal to 4. Years ago, I made my students memorize a few of the Pythagorean triples. I made them do 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, where all of these last numbers are the hypotenuse. So if your hypotenuse is those, well, if I have a 3 and a 4 as the 2 legs, then the hypotenuse will be 5. If my 2 legs are 5 and 12, then my hypotenuse has to be 13. All of these fit the Pythagorean theorem. And I had a student, let's see, it was my 3rd year of teaching, and this is my 26th year of teaching. So Liz Davis, don't know what she's doing these days, but she's still a legend because she created a song, and I have taught it for the 23 years since then. And she, in order to memorize these triples, and they show up on the PSAT, the SAT, all that kind of stuff, she would sing 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. You sing it enough and you kind of get it in your brain, you'll recognize these triples and you'll be able to use it and go more quickly through some of these Pythagorean theorem problems. Now, they're obviously not the only Pythagorean triples, but there they are. Okay, so sine of A means we're going to go opposite. Well, okay, first of all, it depends on, notice on here, we start switching. They have sine of A through here. Oh, and then here comes sine, like we used an angle of A and then we used an angle of B. So we have to pay attention. But this will always, 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 always be the hypotenuse across from the right angle. Okay, so if we're talking about angle A, the opposite would be 3. The hypotenuse is 5. Cosine of A is going to be the adjacent over hypotenuse, and there we go. Tangent of A is 3 over 4, opposite over adjacent. Cosecant, okay, so to be honest with you, when I teach this with my own notes, what I would do is I would say sine of A, cosine A, tangent A, and then next to it I would say sine's buddy is cosecant. And then I would say, I put equal signs. And then I would say secant of A, and I would say cotangent of A. So sine of A is 3/5. That means that cosecant of A is the reciprocal, 5/3. If cosine of A was 4/5, then the reciprocal, secant is the reciprocal, 5/4. If tangent of A, what did we say, was 3/4? Then cotangent of A is the reciprocal, and it's 4/3. And so sometimes writing them, do you see how this one leads us nicely into that? I think that's a little nicer. Do you know what? Before I give you the notes, I'm going to take these boxes here and put them over here, and take these boxes here and put them over there. So don't use my key, or I'll fix the key. I'm gonna write these up here, and I'll change the way it looks before I give you access to this. Okay, so now let's do sine of B, cosine of B, and tangent of B. Say what those equal, and then sine's buddy is cosecant of B, and then cosine's buddy is secant, and tangent's buddy is cotangent, and we're going to set them up so that they're next to their buddy. Okay, so now we're looking at angle B right here, and across from the opposite will now be 4, so sine of B is 4 over 5. Cosine of B, the adjacent, is 3, the hypotenuse is always 5. Tangent is going to be 4 over 3. Therefore, let's take their reciprocals. This becomes 5 over 4, this becomes 5 over 3, and this becomes 3 over 4. Let's see. I'm going to point those out over there. Okay, does that make sense? Okay, so now they have given us information. Find the missing sides of they want us to find everything else about this triangle. Okay, angle A. So notice we know this is an angle because it's capital. So I'm going to label this angle 26 degrees. And then little c is across from here. This is 14. And so now we need to find little a. We need to find little b. We need to find big B. Okay, so let's, what we are going to do, hang on, let me find Desmos. Where are you, Desmos? There you are. Well, that took a little bit. Okay. Well, what am I doing? You know, my kids are better at using their iPads than I am. I mean, I'm not bad, but, you know. Okay, so let's find that angle. So what I know is that the whole triangle adds up to 180. If I subtract away 90, I'm already at 90. So now I can subtract away an additional 26. I can type them all in, but next time I won't do all that. I'll just say 90 minus 26 and get that 64 that way. And so angle B right here is 64. They told us angle A was 26. They labeled angle C as 90. And then what did they tell us? They told us little c was 14. And notice on here, we are working in degrees. So I need to come over to Desmos and change it to degrees. So anytime you hit the button sine, cosine, or tangent, you need to make sure if your angle is in degrees, you're in degrees. If it's in radians, you should be in radians. Okay, so I am looking for little a. So I'm going to say that sine of 26 is equal to a over 14. That means I can multiply both sides by 14. And 14, go find my function, sine, oh, it's at the top, yay, of 26 is, and did I switch my mode? I sure did. I'm in degrees right here. Is about, so sine of 20, a is about 6.137. So 6.137. Now let's find B. I can use either the 26 or the 64. It'll work out either way. But I'll say cosine of 26. Just in case I don't know how to subtract and my answer for 64 was wrong, let's use the original one. So cosine of 26 equals B over 14. So 14b will equal 14 cosine 26. If they ask you for an exact value, this is exact. And if they ask you for the decimal approximation, that's where we're plugging it into our calculator. And it's approximately 12.583. So this is 12.583. Technically, there's an approximation here and here. Okay, so far so good. Let's see. We did the first one. The next one, they tell us little c and b. Okay, so they've given us little c here is 109. They've told us little b over here is 91. I have to do Pythagorean theorem, and this would be little a. So I'm going to say a squared plus 91 squared equals 109 squared. These numbers are annoying. A squared will equal 109 squared minus 91 squared. Now let's go grab Desmos. Come back, Desmos. See, I'm a little congested. I'm sorry. I don't know what just in time for Thanksgiving. Okay, 109 squared minus 91 squared. Oh, that looks like a perfect square. So now we're going to take the square root of that. I was right. Okay, so little a here is 60. So then we said little b was 91. We said little c was 109. Apparently that's a Pythagorean triple. Who knew? Okay, so let's look at the angles. So now if I want to find angle A, I can say sine of A is equal to little a over 109. Little a we just found to be 60 over 109. And so we have to, in order to find the angle, you always have to you have to undo sine. And we undo sine by taking the inverse of sine, or the arc sine, which we're going to talk about later. So we're going to do, nope, not there, sorry. We're going to do inverse sine of that ratio of 60 over 109. And we are still in degrees, so A is about 33.398. We can do 90 minus that angle to find the other one because we know angle C is 90. We just found angle A. We said it's approximately 33.398. We could subtract and get, let's try that. If I take 90 minus 33.398, I get this number. Let's also practice, if I said, if I want angle B, sine of B would be equal to 91 over 109. So let's see if that matches. It better. If not, I don't know what to tell you. 91 over 109. And look, there they are. They round to the same. They're a little off in the decimals, depending on how many decimals you have, but I rounded here. There, so anyway. So what did we say this was? 56.602. Very nice. Okay. So now they've given us secant and cotangent. So let's look at this first one. So secant of A, so here, I sometimes forget. So what I would say is secant's buddy is cosine. So cosine of A is going to be the reciprocal, 12 over 13. So cosine, here's our hypotenuse, always. And here of A, this is the adjacent, would be 12, and the hypotenuse would be 13. And if you remember our song, 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. 5, 12, 13 is one of our triples. I see 12 and 13. 13 is the hypotenuse. That means this other side has to be 5. So we don't know we know angle C. We know that little a is 5. We know that little b is 12. We know that little c is 13. And so now we can find angle A using one of our trig ratios. Let's do, I don't know, sine of A equals 5 over 13. And then we'll say sine of B equals 12 over 13. And now when we grab Desmos, where did it go? We can use we have to undo that process by using the inverse sine. Inverse sine of, and I could pick cosine, I don't need another parentheses, 5 over 13. was this one. Let's see, inverse sine of 12 over 13. And you know how one way we can check to make sure that we did this right? If I take these two, if I add them together, 22.619864, that's a whole lot of decimals, plus 67, okay, plus 3,80135, 05. Well, okay, so I've rounded, and so if I do 498, and look at that, now we're getting to 90. If I actually took those two exact values, if I said inverse sine of 5 over 13, and then I said plus inverse sine of 12 over 13, it's going to equal exactly 90. Very cool. Okay, so this one, A, was about 22.61, well, actually 620. And then the other one becomes about 67.380. Have a happy Thanksgiving. Bye.
Sorry.
No worries. Okay, so let's finish this. So we have 22.620 and 67.380. And now we have one more. Okay, they're telling us cotangent. Well, I think in terms of the reciprocal. So tangent is going to be the reciprocal 3 over 2. And so tangent of B, opposite is here, adjacent is here. And now we have to use the Pythagorean theorem. I want you to find the exact value. So 3 squared plus 2 squared will equal little c squared. So 9 plus 4 equals c squared. I see 13 equals c squared. Therefore, c itself is exactly equal to the square root of 13. So little a was 2, little b was 3. Yep. And you know what? I am wrong. Did you see what I did wrong? I should know better. Let's blame it on Thanksgiving break. These were actually the little values, and I put them where the big ones should go. So my bad. I caught it, but that was wrong. Okay, so we'll do inverse tangent. So tangent of A is equal to 2 over 3. And so we will say, let's clear out some of the clutter. Where are my options? Oh, come back. Where does it say function? Did I scroll out too much? What did I do? Oh, okay, never mind. All right. Inverse tangent of 2 over 3 gives me that angle A is about 33.690. And then, you know what we can do? We can actually come back over here and say, well, I think we can, 90 minus that angle. And so angle B would be 56.310. And C, we already knew to be 90 degrees. All right. You have to practice all things right triangles because they are the foundation for the rest of the year. So, like, subscribe, comment, and go practice.